Okay, moving on to postal codes here. I'm going to try to see if I can speed this up a little bit. With my postal codes, these are the letters that cannot begin the postal code. They're fine in other positions of the postal code. So if I look at this quickly, I'm going to have a letter followed by a digit all the way across. There are 6 letters unavailable for that first position, meaning there are 20 that are fine. There are 10 digits available to me. The 0 is perfectly fine. When I get to this position, all 26 letters are available. Digits, again, there's no problem with repeats. It says that repeated letters are allowed and any digit is allowed. And so 26 and 10, multiply those out. The first letter of the postal code is the province. And so these are the Ontario starting letters, having different postal codes. So very similar to the previous question. Again, 6 positions. These will all remain the same. I still have all the same values throughout, but again, as my starting point, I have K, L, M, N, P, and so 5 possibilities there. The first digit is a 0 if the region is rural. Okay, so same sort of thing. So again, even before I read the question, sometimes I'm just going to draw the lines in. I know there are 6 spots to fill, and so that's where I'm kind of going here. First digit is a 0. So this is a 0, meaning I know there's only that one possibility. The rest of Ontario. Now this one actually is interesting because even though I usually suggest that these questions are all independent, here we know these are actual real rules. And so the fact that we're in Ontario means we should use the value from the previous question for our start here. There are 5 starting letters available in Ontario. There's a 1 possibility for that second letter or that second character. It's a 0. And then after that, we have these are possibilities. And of course, we're multiplying those out. I don't have a calculator with me. You don't need to watch me punch things into a calculator anyways. How many 5-digit numbers can be made from that? Repeated numbers are allowed. Okay, so 5-digit numbers, we have 7 possibilities there. And yeah, repeated numbers are allowed, so that one should be pretty straightforward. There are 7 different values that could be that first position. And the same thing for all the others. I can use that 3 all 5 times if I want to, or the 4 and so on. So there are 7 possibilities times 7, whatever 7 to the exponent 5 is. No repeated numbers, so this is sort of the more traditional question, but again, the setup can be exactly the same. There are 7 possible values here. It can be the 3, the 1, the 4, the 6, the 2, the 8, or the 7. Whichever one has been used is now no longer available for the next position, and so on, and so on. This can be done with a more traditional permutation as well. You can sort of, forgetting about the fact that they're numbers or anything else, there are 7 of them available. I'm trying to place 5 of them. So that's a classic T75. 7 items available, 5 to be placed. Four-digit numbers divisible by 5. Okay, so now we're getting into some more advanced stuff here. I said in one of the earlier videos, I think, that when I'm dealing with digits, or when I'm dealing with numbers specifically here, I'm looking to fill, I guess it should be when I'm dealing with any of these, I'm looking to fill kind of the most specific spots first. So here, 4-digit numbers divisible by 5. This is the kind of trickiest or most specific position. This, to be divisible by 5, will have to be either a 0 or a 5. So there are only two spots or two options available to me there. After that, because in this case, repeated digits are allowed, there's really nothing else that's particularly specific. I was thinking ahead to part B when I started talking here. So that leaves me 0 to 9. So I have 9 possibilities out here. Right, because digits are allowed. So even if I use the 5, it's fine to use it again. And then after that, in position 2, anything can be used. And in position 3, anything can be used as well. And so that's 18, 0, 0. Now, more interesting is the next question here. 4 or 5-digit numbers evenly divisible by 5. Repeated digits allowed. Okay, so actually the last one is probably the one that's the more interesting. Now, 4 or 5-digit numbers right off the top, they're telling us really there are two questions to be done here. I can't kind of deal with those at the same time, so I'm literally going to do two separate questions here. So my 4-digit numbers evenly divisible by 5, but again, repeated digits allowed. Well, I actually already did that one. I just did it above here. So I kind of know there are two possibilities for that last spot. There are 9 out front. So again, 1800 basically there. I can follow the exact same logic for this one though. I can have the 0 or the 5 in that last spot. So two possibilities. My first digit can be anything but the 0. And then, whoops, a bunch of 10s in here. And so what's that? So this was 1800, kind of running out of room here, 1800. This one's going to be 18,000, I would say. Hopefully I'm not messing this up. And so that is 19,800. And then last one here. 6-digit numbers, repeated digits not allowed. So this is sort of where things get a little tougher. When I first start these questions, so again, I'll go with my 6 dashes. We said I could have a 0 or a 5 here. There are two possibilities. When I then jump to the front, I recognize here I can have anything from 1 to 9. Oh, but wait a minute. Unless I used the 5 before, in which case I can only have 1 to 4 or 6 to 9. So as soon as I catch myself in a moment like that, I'm sort of pausing and wait, well, there's 9 possibilities sometimes, but there's only 8 possibilities other times. I have to actually treat the question, kind of like I did on the previous step, as two separate questions. Just slide this over. Oh, didn't mean to do that, but I guess it's okay. So now I can't quite handle that the same way. I need to handle it with the 0 specifically. When the 0 is there, there's only one way for that to happen. That leaves me 9 possibilities out front and no repeated digits. So now I've used up my 0. I've used up some other number out front. That means I'm going to have 8 values left here, then 7, then 6, then 5. But again, that's only the possibility with specifically ends in 0. And so I'll now have to do the exact same thing for ends in 5. Again here, one possibility out front, sorry, one possibility on the end. When I get to the front though, I'm going to have 1 through 4 available to me. The 5 has been used up. The 0 is not available. And 6 through 9. So there are 8 possibilities here. Now I've used up 2 numbers, but the 0 comes back into play. So I will have 8 values left again. Okay, so again, the 5 is not available. Whatever wasn't used from here. So I sort of think I have 7 values transferring from here that are available. Oh, but wait, I could also have the 0. So now there are 8 possibilities there. And then the rest of it should be fairly straightforward. 7, 6, and 5. And again, if I multiply each of these out, I get 2 sets of values, or 2 numbers. I'll add those together to get my final answer. So I made a bit of a mess of this, but basically this first value is 15,120. I had to pause so I could figure that out. My second value is 13,440. And so add those together. Very apologetic, very apologetic. I apologize very much for this messy solution. Did not plan my space well here. And so add these up. We've got 0, we've got 6, we've got 5, we've got 8, we've got 2. 28,560 values that are 6-digit numbers, evenly divisible by 5 with no repeated values. I'm not going to try to list those ones off.